Hello, this is the Physics MC, and in today's lesson, the goal is to use optics concepts. We're going to determine how glasses help our eyes see using different ray diagrams, and we're going to draw ray diagrams for multiple lenses and see how that works. So to do that, let's start with just a diagram of what actually is going on in your eye. So let's say this is a line here, the principal axis. And in your eye, you have a lens. Doesn't look exactly like that, but it behaves like a convex lens, just like that. With any convex lens, it has a focal point. So, but we'll touch in on that. So, let's say that light comes in from a source, from a faraway source. Say red light's entering your eye. It's going to hit this lens. And as soon as it hits this lens, it's going to bend because of Snell's law. And once it leaves this medium, it's going to bend again. So light's going to travel that direction. We can draw another light ray coming in, and as it hits this medium, it bends, and it bends again as it leaves this medium, and it's going to kind of end up this way. So right here where those two lines converge, that is your focal point of the lens of your eye. Now it becomes an issue if your eyeball, for example, let's say this is your eyeball, and your retina, meaning the back of your eye, is not, so the back of your eye here is not, or here, is not at the focal point, meaning that whatever you're looking at is not converging on your retina, so whatever you're seeing is going to be blurry. That point is actually spread out over all this distance. That's not good. So we can correct that with glasses. That's a common thing people do, is they wear glasses and it helps them see. Well, how does that work, you may ask? Well, let's draw a ray diagram and think about how that works. So let's continue these lines here. I'm going to erase some of them by accident. Okay, so what we could do is we could potentially put a lens here, maybe like a concave lens. And I'm drawing it green here. We can put a concave lens here and see what happens to the light when it hits this new medium. So maybe we'll go blue lines here. So as light comes in, this light comes in on the same path, but now it's entering a new lens before it gets to your eye. It's going to bend out again. It's going to hit the top here, and now it's going to bend in or down and down a little bit more. It's going to meet at a different spot. Here we can think about this light ray doing the same thing. It's going to bend out a little bit, bend out a little bit more. It's going to hit a different spot on this lens. It's going to bend in and then in again, and it meets back here rather than here. So your eye, we'll see that. So let's think about a more detailed ray diagram here. Maybe we can calculate focal points of lenses. Like when you look through your eyeglasses, I guess before we come back to that, what would a convex lens do? Rather than a concave, what would a convex lens do? Well, we can say that a convex lens is going to converge those lines before they get to your eye, so it's actually going to move that those rays closer. It's going to move them actually closer, or even farther this way. So when we give this a terminology, if the convergent rays is on this side of your retina, meaning it's like in the middle of your eye, it's not on the back side of the retina, we call that a nearsightedness, meaning that you have to use a concave concave lens to diverge those rays so that you could move that image back. So people that are nearsighted, they have lenses for their eyes that are shaped with a concave, meaning the center of those lenses are typically shaped like this, where they're thinner in the middle and thicker on the edges. so it behaves like a concave lens. This is a simple drawing for a concave lens, meaning that it's going to diverge those rays as they come in, so that the focal point can, because you actually get, as it hits your eyeball, it'll move that focal point back where those lines converge finally. So your eye hits here instead of up here. Where unlike if you're farsighted, then that would be like if the rays came in and if the rays came in and your retina, let's say your retina's here, and they're actually converging back here. Well, we'd want to move that closer here. So we'd have to put a converging lens, meaning a concave lens, so it actually converges quicker, so it hits that spot sooner. That's probably too much, but you get the idea. So this would be used for farsighted people, where a concave would be used for nearsighted people. So let's do a more specific ray diagram here. So here is your lens in your eye, and you can adjust that. Let's give it a focal point here, and let's do a arrow as an object. I want to see what happens to that arrow. So I can draw one light ray entering this, and I can simplify this parallel to focal point, and then focal point to parallel. So right now that image is formed right here. It's upside down, and it's this point on the arrow is actually being spread out over this whole range. By the time it gets to the retina of your eye, it should be here, but it's actually being spread out. So that point looks like a big area, so it appears blurry. Well, how do we fix that? Well, this would be a nearsighted person, so we would need a diverging lens, because we'll move it back further. A converging lens would move it this way. Diverging lens would be this way. So this would be concave. This would be convex. So erase those real quick. And let's put a concave lens in here. Let's draw that and see what happens to this image. So if you have a concave lens, like glasses, and I'll draw a new ray diagram for this, maybe go blue. So what's going to happen to this is it's going to diverge. Yep. And we can trace this back. This is going to go through a different focal point. It's going to diverge. Trace this back. And now we get a new image. This new image is formed right here. We're like, wait a second, my eye can't see that. Well, remember, we have a light source. We have another lens here in your eye, meaning that the object of the image of the first, the image of the first becomes the object of the second lens. So when you have multiple lenses, this image that's formed becomes the object of the second. So meaning that we can assume that once this image is formed right here, once the image is formed, we can now treat that as the object for this lens right here. So now let's go through and trace the ray diagram for this. Let's do that in red, so it's a different color here. So now we can treat that image that's formed as a new object. We can go through the focal point, boom, and then we can go through the focal point here of this lens, parallel, and where does it end up? Look at that. It converges right on the retina. The person sees it right in the retina. So this image that's formed from this lens actually was transferred over to a new image. So what does this mean? What are some applications of this? I mean, well, we can use the concept of optics. We can use images that are formed to form new images. kind of neat how optics works that way. Like the first one, we formed this image right here. We formed that image with this lens, and we use that image to form a new image from this lens right here. We can do a third lens if we wanted to, but basically that pattern continues. If we wanted to put a third lens in here, well, we can use this image to form some new image with a third lens, or a mirror maybe. So that's kind of neat. You can imagine how complicated this could get if we had multiple lenses and multiple mirrors. I'll give you a chance to reflect on that one for a bit. Pun intended. Reflect. Sorry, that wasn't enlightening there. But anyway, so let's kind of just review here. So can we determine how glasses help our eyes see? Well, yeah. You can have nearsightedness or farsightedness, and a concave lens or a convex lens can move that image forward or back so it gets to your retina. Can we draw ray diagrams for multiple lenses? Well, yes, we can do that by assuming that the image of the first object, this is image 1, becomes object 2. Object 1 forms image 1, and then image 1 becomes object 2, which forms image 2. So yeah, it continues that pattern. Anyway, hopefully you had fun. I know I did. There's lots of applications to this. I mean, microscopes are based off this concept. I mean, you can adjust you can use lenses to adjust how clear something is by moving it forward or back, or the strength of the lens. So there's lots of applications to optics, and hopefully this helps explain one of them in terms of how glasses help your eyes see. Your eyes are optics. So have a great day, and